How many questions are on the final?
I don't know. How much time do we normally have for a test?
2 hours.
Yes, about 2 hours. How much time do we have for the final?
2 hours.
No, how many questions?
But no, I don't know. But it's going to have to be about as long as a normal test. That's the point. So what exactly will I not put on there, we'll all find out when we take the final. What could be on there? Yeah, I said we. I don't know. I go into a blackout state, make the test. I'm like, what did I just do? Yes?
I just want to clarify for the hypothesis testing, we put 5 steps, like the 5 steps. Is it going to still be set up how it always
Yes.
Okay.
And I will give you the 5 steps. I'm not saying you have to memorize them. I'm just saying know how to do each step. Yeah.
Okay.
Everybody good? You guys all right back there? I see some people that came in late. You might want to get something later, not right now. Too late. So let's try this out. Anybody need to borrow calculators? Do that right now. That will help. Classic, I like. Good new one, yeah. All right. So let's all do this together. If you missed last time, you're gonna want to get this from me, this handout. So the basic idea. I'm not going to redo the whole lecture I did. I just want to do a real quick example to show you how the calculator does its business. But the main idea behind correlation is seeing if two variables seem to have some kind of relationship. We don't know which one causes the other one to change, or if there's a third thing behind the scenes causing both of them to change. Okay? So for example, if I had, what you got, Chuck? Let's make up some data. 7, 8, 15, good job. 19, and 22. Okay, so let's all use that for list 1. So that's going to be my x variables. Let's say that's the number of coffee somebody drank per week, right? Several people.
Thank you.
And then over here, let's put, let's see, what we got, Jeff? Let's do 58, 68, 72, 79, and 73. Okay, I like it. So that'll be your resting heart rate. Why not? Almost doesn't matter what they are. So I have 2 variables, and it kind of makes sense. I might want to see how caffeine or coffee affects resting heart rate, if it does. And obviously exercise also does too. Can anybody tell me, just by looking at the data I've got in there, would this be positive or negative correlation?
Positive,
Why positive?
because the distance between L1 and L2 seems like far away. I mean,
Uh-oh. So as x increases, what does y generally do? As x increases, y also increases. I like it. That's a positive slope, right? So that's going to have a positive. Does that always follow what I just say in this list? Is there one point that kind of bucks the trend? Yeah, that last guy. So that's the guy who drank more coffee, but maybe he's in better shape, right? You guys kind of with me? Yes? Okay. So that's what we're trying to capture with what we're going to calculate is how strong is this relationship? And then also, visually, if I plotted those points, is there a line that would best average where those points are? That's the line of best fit. Okay, I like it. So where do I go from here, besides waking my calculator back up, to calculate the line and the R, the strength of the relationship? Where do I go?
Stats, Cal, 4.
Stack out 4. I'll tell you where to go, Jeff. Stat, calc. And then this kind of makes sense. This doesn't make sense. But they have a whole other, if you don't want A to be the slope, you can have B be the slope. These both do the same thing. We're just going to use 4. Now, this is where the fun comes in. Let's see. Everybody with me so far? If you have an older style calculator, it might just say Lin Reg on the screen. You just hit enter because it defaults to list 1 and list 2. Okay. So I'm going to go down to calculate. Calculate. So let me know if you didn't get everything I got. It's okay. It's all right. Some of you guys are going to be missing something. What's wrong with you? No, I'll get you. Anybody else missing? Is everybody, all right, everybody who's playing along with me, did everybody get everything that's up there? If you didn't, it's not your fault. I got you. Raise your hand if you didn't get everything. Okay, I like it. This will make it easier. I can just focus on, I can just do yours. I'm going to totally shoot a cap. What I'm about to do is not going to do shit.
Well, I
Everything's going to be off by 2.
because I don't think
Imagine if
the
every single
list is
thing.
at 7.
Look at you go. All right. Stop. Oh, you got different numbers, though. That's not, you got very. Oh, you put 45. This is.
I get wrong numbers.
So you need, let's see. And you need
No, absolutely not. No, not a big
and this is just a.
I can write it.
Did I see?
And we're just doing an example. Sorry.
Yeah.
Okay.
L1, L2. I'm getting the different numbers.
Like, either side of psychology notes in here. My life is a dress.
Yeah.
Oh, see, this one you heard.
Oh, this is yours.
Cones.
L1, L2. All right. L1, L2. Oh. Frequency list. It thinks the frequency is L1.
Oh, yeah.
So guys, help me out. Technology moments suck for me because so many things can go wrong. Everybody cool? Everybody got that? If you didn't and you're not saying anything, it's your choice. Forever hold your peace. All right. So this would be a little bit evil to put on the test or something, because look at the R value. Is that strong? It's almost, sort of, maybe. Right? So let's see why. Let's see visually why this R is really not very close, but it is sort of close to 1. Right? Yes?
Is it because it's 0.81, and then if it was like 0.85, it'd be closer?
Well, yeah, that'd be better, but like 0.93 would be really in your face strong. 0.8 is kind of like on the cusp. It's like, Okay, I like it, maybe.
Which problem is asking? This one you just.
This one I just made up.
Oh, yeah.
Came right out in my head. Alright, that's always exciting. Where do I go? If I hit graph, that's very anticlimactic. So 2 things I've got to do. Who knows the 2 things I have to do to get the right points in the right line?
Snap one on.
Yeah, let's make sure everybody's stat plot. So hit second y equals. Let's make sure everybody's got their first plot turned on. Make sure that only the first one's turned on. Everybody with me? Second y equals to get the stat plot. Make sure the first turn on, and make sure you got scatter plot, the points selected. And you can also see all the other shit you could have done if you would have just looked in the manual. Yes?
If I scroll down, it says 5 plots on.
That'll turn all the plots on.
Oh.
You don't want to turn all the plots on. You just want the first one on. All right, not seeing anybody. 3 minutes from now, don't say, yo, no. Right now, tell me if you're having trouble. All right, that's nice. Everybody's got it turned on. I still don't have shit showing up, so where do I go next?
Zoom.
All right, I can do Zoom.
And then
Zoom stuff.
Yeah, dude, Zoom, and I just hit the number 9. I love everybody scrolling down. Just hit the number 9, bam. So there's a point. You can see that they're not really lined up perfectly, but they're not too crazy, right? So the 0.8 kind of makes sense now. Because again, the more perfectly lined up they are, the closer R should be to. The closer R should be to. That sounds like a Star Wars robot. Yeah, it should be closer to 1. They're all lined up. How do we get the line to show up?
Y equals.
Y equals. Kind of makes sense. Y equals. And I don't know if anybody wrote down what our line was. Scheisse. I forgot. Yeah. AX plus B. So somebody write this down. 0.955x plus 56.4.
So for the B, we just get like the decimal, just a number.
When you're not sure, 3 or 4 places.
Okay.
Yeah.
Will you specify?
No. Because I'm an asshole. All right, so y equals 0.955x plus, what was it, 56.4. So now if I hit graph, it'll work because it's already centered on my data points. The Zoom 9, when you put new data in, that tells the calculator to go find it. Costs $100 freaking bucks. It should be able to find some points. And then if I graph, now I get. So that line is the graphical average of those data points. And R is sort of related to a 2-dimensional standard deviation. It's really cool because when I get a new distribution, what do we always figure out? The mean and the standard deviation. This is a 2-variable thing. Visually, the mean and the standard deviation. It's kind of, to me, it's neat. I don't know. It's okay. I'm used to being the only one in the room finding something neat. All right, and that's what you're going to have to come up and show me when I give you that problem on the final. You're going to have to show me your scatter plot and your line of best fit. Okay. Good? All right, so let's do this problem. Please don't worry about this side that's got the colors and it's got a graph that looks like Jabba the Hutt. Worry about the more boring side. The side says side 1. Isn't that crazy? That's the correlation problem I want you guys to do right now.
You still haven't gone over any types.
Nope, we're going to do that after this. Because we're only going to do one section of it, really. Yeah.
Wait a second. Oh.
It was over, so I didn't know what was going to happen.
I missed
So a real quick tip before I forget to tell you. Normally in equations we make the percentages into decimals. Since the whole point of this is to create our own equations, you can just leave the numbers like this. Because you're going to create an equation that can handle percentage numbers if you want to. You can make it in decimals if you want to. It's just your answer is going to be a little bit freakier. You guys, so L1, L2. Who needs this, by the way? This one about beer and taking tests. If you don't know what I'm saying, then you need it. Everybody else is okay? Beer and taking tests. Because on the back side, it's got the steps for doing all the shit I'm asking you to do right now. So that's not a bad sucker to have sitting out next to you if you're not sure about the steps. Oh, let me give you some other stuff too. Yeah, here we go. Marianne her stuff too.
No problem. Thank you.
Oh shit, this should do this too.
Wait, did you say to enter it as a